Moving on to the use case diagram for the Etica e-money system, we see that there are several different types of actors. We have the users, such as the customers, the finance officers, the CSOs, and the compliance officer, and also some of the systems that are involved, such as the Maybank e-money platform, the claims core system, and also the Bank Negara Malaysia. And we also see abusers, fraudsters, attackers, unauthorized users, which abuse or misuse the systems, such as making fraudulent payout attempts, tampering with the transaction records, so on and so forth, which we have outlined ways to mitigate these actions. And also, we've outlined the use cases that the different entities can take action on, such as executing e-money payouts, notifying payout statuses, and also withdrawing money to the bank accounts, such as what the customer can do. And all of these are outlined in this diagram. Thank you.
Assalamu alaikum, doctor. So now I'm going to be explaining about the activity diagrams. So now for the first activity diagram, which focuses on executing e-money payout. So e-money payout starts after claim approval, and then payout details are validated, and then after that payout record is created. E-money credit is initiated via Maybank e-money platform, and then if it's successful, status is updated and customer is notified, and if failed, payout rejected and failure notification sent. And now for the next activity diagram, which is for viewing payout status. So user requests payout status, and then system authenticates and authorizes. So if it's authorized, the status is displayed, and if it's not authorized, the access is denied and locked. Now for the third activity diagram for UC006, which is with withdrawal of the bank account. So customer requests withdrawal from e-money wallet, and system identifies user and validates request. Transaction is created and transfer is processed via payment gateway and bank platform. And then logs are captured for success, failure, and exceptions. For example, low balance, invalid request, unauthorized access, and etc. And now for the fourth activity diagram, we invest into Etica product. So customer selects to reinvest from e-money wallet, and customer chooses an Etica product. System checks balance and policy eligibility, and then if eligible and sufficient funds, the reinvestment is processed and amount is deducted from e-money wallet. And now for the next so now for the next one, which is run reconciliation job. Finance officers task reconciliation, and system collects and compares transaction records. And then discrepancies flagged and officer alerted if there's any, and then compliance report sent to BNM and teams. And then for the sixth activity diagram, which is resolve reconciliation job. So system displays a mismatched transaction, and finance officer investigates the issue. Officer resolves via adjustment, write-off, or confirmation, and system updates status and logs the resolution. And then case returns to reconciliation workflow. Now for the seventh activity diagram, which is to generate and submit BNM compliance report. Compliance officer initiates BNM report generation, and system gathers payout and reconciliation data. So data is then after that is verified for accuracy and compliance. So if it's invalid, so error is logged and officer is alerted and process terminated. If valid, report created and formatted and secured. Audit logs created and report saved. And then after that, report sent to BNM submission gateway, and then gateway returns success ID or failure messages. So this is all for the activity diagram. Now I'm going to be passing to the next member to continue.
This is the UML domain class diagram for the Etica e-money system. So we're gonna first start from here. Each customer owns a minimum of only one e-money wallet, or they can have so many e-money wallet. And here, each customer only have maximum one user account and a minimum one user account. So they have at least one user account at most. Every e-money wallet can record no transaction at all or many transaction. The e-money wallet is linked to the audit log. Somehow they are linked. The e-money wallet somehow can credit the audit log. They are linked somehow. And payout is linked to the audit log by credits. And for this one, the e-money wallet is somehow linked to the reinvestment with users. And reinvestment is somehow linked with the insurance product. They somehow targets the any insurance product. And for this one, the access control somehow checks the user account. And for this area, the audit log somehow they're linked with the compliance report. They might use in a compliance report, the payout system, they are linked with the wallet transaction. Yeah, so that's it. That's the UML domain class diagram.
Hello, my name is Ahmed Kamal Ibrahim Suleiman, and today I'm going to explain about the interaction and behavioral modeling overview. In this slide, I will explain about the state machine diagram for our system. This diagram shows the payout change its state step by step from the start until the end, and it helps us to understand the system behaviors over time. This process started by submitted state, and this means that the payout request has been created by the system, and after that, the system moves to validating state, where it checks whether the payout details are correct or not. If the validation is successful, the system continues and the payout is marked as completed, and this means that the payment has been successfully processed. However, if the validation fails, the payout moves to failed state, and in this case, the system stops the process and notifies that the payout was not successful. This state machine ensures that the payout can only be invalid state, such as submitted, completed, or failed, and prevents the incorrect and unexpected system behavior. In this slide, I will explain the sequence diagram, which shows how different system components communicate with each other over time. First, the process starts when the report or request is created. The system then collects the required data and moves the validation steps. In the validation step, the system checks whether the data is correct or not. If the validation is successful, the system formats and secures the data before submitting it to the external gateway. The gateway then sends the response back to the system. If the gateway response is successful, the process is accepted and completed. However, if the validation fails or the gateway returns the failure message, a process is rejected and ends. Overall, the sequence diagram helps us to clearly understand the message flow and the order of communication and the responsibility of each component, which supports the correct implementation and testing of the system.
Hi, I'm Muyuki. For PR2, our main challenge was translating complete payout and reconciliation process into consistent UML model. We need to make sure the use case, activity, diamond class, and state transition diagram all reflect the same system behavior and stay traceable to the group defined in PR1. Through this process, we learned that clean requirement and earlier agreement on system scope are critical. And the activity diagram help us identify missing step and execution flow that was not obvious at first. As a team, we share the process regularly and review each other's diagram to improve accuracy and consistency. This cooperation helps us refine our model and better understand how different perspectives of the system fit together. Thank you.